Welcome to Module 204A. In this section of the course, we're going to be mainly talking about motor controls. So we're going to look at different types of electrical control drawings that go along with that topic. A lot of these types of drawings you've already seen in first year and also within the drawings section of this course, but we're going to take a look at them with the specific idea of motor controls in mind. This module has three objectives. First, we're going to identify the four basic types of electrical control drawings. Then we're going to look at the symbology that's used on those drawings, specifically related to motor controls. And then we're going to look at the sequence of operation of a control circuit. Let's start with objective number one and look at the four basic types of control drawings that we have. A very important skill set that we have is to be able to read electrical drawings. It's very important for us to be able to accurately define what's inside these drawings and identify everything that's within them in order to properly analyze and troubleshoot circuits. So we're going to be looking at our wiring diagrams, block diagrams, interconnection diagrams, and our schematic diagrams. As the name would imply, the purpose of our wiring diagram is to show you the wiring within a component or within a system. For example, what we have on the screen is a security system, and we can identify different parts, such as the alarm switches, the transformers, the bells, and the main alarm panel. The intent of this drawing is to be able to give you an accurate depiction of all the wires that are required, where they're going to come from and go to, and how many wires we would require per cable. Typically, wiring diagrams will keep the relative position of all the different components in their right position so we can identify them when we get into the system. A lot of wiring diagrams will also show you different depictions of types of wires, whether it is field wiring or if it is interconnecting wiring inside the factory. So be aware of that as well. Block diagrams use simple geometric shapes in order to represent different components within our system, and they are the simplest type of drawings that we have. We also have a number of different types of block drawings that we can have, such as riser diagrams, which would show us a block diagram with relative location between floors. These are not going to give you a lot of detail as far as where your conductors go or what should be connected inside each different device, but it does show you the relationship of each of these components with each other. The next type of diagram I have is called the interconnection diagram, which in reality can show up as a pinout diagram like you see on the bottom right hand corner of the screen, which we would use for wiring cord ends. However, it can also be a termination schedule, and this is still considered to be our interconnection diagram. With the termination schedule, if we take a look at cable number one is going to have two different conductors in it, and this tells us what I'm expecting to find inside there for colors. It's also going to tell us which color is going to go to which terminal. So my black is going to go to terminal 1, my white is going to go to terminal 2. And after that, it also tells me where it's going to run to. This is going to relate back to the wiring diagram. So if we were to look at the wiring diagram, we would be able to find terminal 1 and terminal 2. We would see a cable coming from those terminals, and that cable would be labeled with a 1, and we would see at the other end of that cable would be the transformer. This is really handy when you have larger manufactured machines that you have to do some field assembling with, and they send you the cables to go along with it. The termination schedule is going to tell you which cables are going to start and finish where, and it allows me to be able to organize my cables in such a way that I can put them all in at the same time if they're going to a similar destination. Some interconnection diagrams on larger, more complex systems with multiple electronics or components can actually span multiple pages. They're still giving us a reference between components, and they're still showing us what our pinouts are going to be. But now we'd have to use a page reference in order to find what the complete system is going to look like. Schematic diagrams are designed to show us the electrical sequence of operation in the simplest possible way without any regard at all to the physical location of the components. In fact, pieces of the same component can be completely separated inside a schematic diagram. We always organize our schematic diagrams in the same way, where we're going to have the control devices on the left-hand side and any load devices on the right-hand side, and our schematic diagrams could show multiple different voltage systems like you see on the screen here. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.